Hey there, welcome everybody to the Daily Space Weather, and we're running a little bit late today. Pardon the pace. We may be talking about space weather at a fast clip. Here's sunspot 2860 setting in the southwest. Let's take a look at the sun's magnetic fields in colorized magnetogram. So here's the southern hemisphere. We're looking at sunspot 2863 over here. The most likely place for additional activity here. We have relaxed our coronal mass ejection watch. And we're not expecting any major flares at the moment. And we'll be viewing sunspot 2863 to see if it continues to progress. It has grown a little bit here. This is the past day. Colorized magnetogram there. It's grown a little bit. It's not super complex magnetically speaking. Here's a close-up of it. And this is an ionized iron, 171 angstroms. My personal favorite wavelength here at the Smash News Network, least busted name in news. Next, looking at another spectral state of ionized iron, a different number of electrons. It's 193 angstroms. Also from the Solar Dynamics Observatory. Coronal holes in the south as well, in between sunspot 2860 and sunspot 2863. We can expect some geo-affects from this in about 3 days. Nothing yet showing up on any NOAA alerts. And NOAA is quite accurate at forecasting coronal mass ejection coronal hole high-speed wind streams. Coronal hole wind streams. The radial flux has come up a little bit here. And if you're new to the channel, you may not know that the upper chromosphere and lower corona, this area right here, produces a radio frequency similar in proportional output to sunspot number. So there's the 1 year chart of that from Solar.info. The black line is the radio flux, the red line is the sunspot number. Radio flux came up 2 solar flux units since yesterday to 86. So there's the forecast. No space weather in the forecast at the moment. And sometime around late September 5th into September 6th is when the arrival of the high-speed coronal hole wind stream is expected. Let's take a brief look at global seismicity here. It's pretty calm as far as earthquakes go. No major quakes over the past 24. We'll scroll up the list. If we miss anything, just let us know in the comments. We consider it all a collaborative effort. So a deep quake here at the Kuril Islands here, south of Kamchatka Peninsula. It's a 5.2 at over 430 kilometers estimated depth. South Sandwich Islands continuing to shake here. The largest quake of the past 24, maybe that 5.6. Near the Antarctic and South Pacific and South Atlantic tri-plate boundary. It's a tri-plate boundary. Some minor quakes on the east coast of the U.S., a 5.4 at the Southeast Pacific Rise. So nothing to write home about when it comes to seismicity. Largest quake of the past 24 was a 5.7 near the South Sandwich Islands, the most seismically active portion of the planet for the last couple of weeks here. Looking at volcanoes next, Karimsky on the Kamchatka Peninsula is exploding, producing a 10,000-foot plume of volcanic ash. Please don't pole vault the caldera. Suwanosejima exploding as well, 10,000-foot ash plume there in the Ryukyu Islands. White Island, New Zealand, the volcano north of the North Island. Reported minor ash emissions have been observed by surveillance cameras. And a constant glow from the summit crater, suggesting a rise of magma, with temperatures of 5 to 600 degrees Celsius. Pagan now exploding in the Mariana Islands, near the deepest part of the ocean. It's producing a 4,000-foot ash plume. Nevado del Ruiz, 21,000-foot ash plume over Colombia as that volcano explodes. Revenador exploding, 16,000-foot plume of ash produced over Ecuador. Sabancaya, in similar fashion, exploding 25,000-foot plume of ash there over Peru. Don't pole vault the caldera. Visit our websites, though, smashomash.com. Join the Smash team, smashomash.com/Smash team. Here's the GOES magnetometers. And yeah, it's 2 of them now, the GOES 16 and the GOES 17. The GOES 17 is the blue line. The GOES 16 is the red line. And another divergence happening here recently. Let's take a look at the heliospheric current sheet. So as we said yesterday, there's a delay of the arrival of the North Pole-oriented current sheet. And we are expecting the Earth to remain in the South Pole current sheet. Here's the last image. South Pole current sheet shown here in red, North Pole shown in green. And Earth may still be in a South Pole current sheet when we do tomorrow's video. If you're wondering how I forecast that, sorry, it's a proprietary secret, can't really tell you. Here's a line of sight ecliptic plane field plot showing you the solar magnetogram and the same data here from a line of sight perspective. There is a North Pole current sheet over there, and again, we are expecting it to be delayed in showing up. Next, the line of sight coronal hole plot. And you can see this South Pole-oriented coronal hole here. Again, we can expect some geoactivity from that. A little uptick in the KP index, global geomagnetism, in about 3 days. This also shows you the sun's B field in blue. And it shows you the solar cycle progression in the most detail that we can pretty much show. Next, the solar flare probability, still significant here. So we still have about a 30% chance of some solar flares here, mainly from sunspot 2863. The likelihood of seeing any solar flares from 2860 now dropping quickly as it moves around the southwestern limb. KP index currently at 2. Global geomagnetic calm conditions. No major flares over the past 24, just a C-class enhancement here at 2100 yesterday. Only 3 days into smAshtember, and we are absolutely delighted with the month of smAshtember, thanks to all of our SMASH team members. No spikes in the proton flux. Let's take a look at the real-time solar wind here, which is showing some likely erroneous data. And when you see these yellow error bars down here at the bottom, it's an indication that the computer doesn't believe some of the data. And this is what happens when it drops below 1 for the solar wind density, for example. But in any case, we're going to ignore that and report on the current data. Current data is solar wind density, 14.28 protons per cubic centimeter. Solar wind speed, 363 kilometers per second. And we are seeing ongoing error bars here. This data from the Discovery, located at Lagrange point 1. Next, looking at magnetohydrodynamic pressure for the past 4 hours. And this will give us an idea if the data on there is legit. And this looks fairly consistent with what we would expect at about 15 protons per cubic centimeter and under 400 kilometers per second for the solar wind speed. Looks perfectly fine to me. Pretty consistent pressure here over the past 4 hours. Next, ground magnetic perturbations. Changes to the Earth B field, otherwise known as geospace delta B. And since there's a polar excursion going on at the moment, the South Pole is somewhere in the Southern Ocean south of Australia. We show it daily to show where changes in Earth's B field are happening, at least for the past 4 hours. And that refresh, we're going to allow it to play through despite speeding up things here a little bit on the daily space weather video today. And by the way, congratulations everybody who's discovered our channel. So some odd perturbations here happening right around the south magnetic pole. I've never seen anything like that before. You see all these sudden changes there to Earth's B field going on. That is a new one on me. I don't remember ever seeing that before. So something going on there around the south magnetic pole region. Something that we've perhaps never covered on the channel before. And let us know what you think about that in the comments. Next thing we're looking at here is a diagram of the solar system. We'd like people to know where stuff is. It's called Astrography, and here's where it is now. We'll advance it 1 week. There's where things will be in a week. And we're less than a week from the next new moon. Next, the star chart. I'd like to know what's going on above my head, so I use in-the-sky.org. I face my star chart to the south, as I'm facing to the south, and so is my sofa. Anyway, that's where stuff is now. The sun just rose here over Lehigh Valley, Pennsylvania, and the moon should be visible up there, approaching its apex across the ecliptic, which is this yellow line, the path the sun will take across the sky. Today's cosmology segment will be brief, unlike yesterday's, which was over a half hour in length. And our random number is 8, which coincides with low-mass X-ray binary IGR J00291 plus 5934. So this low mass X-ray binary, we're going to take a look at it briefly here. These are the X-ray transient outputs from it. It's hard X-rays from the Neil Gorell's Swift Bat X-ray Observatory. It stands for Burst Alert Telescope. It's monitoring 1,050 objects, including this one, which is a very consistent X-ray source, as you can see here over the past 16 years. Let's take a look at it. Here it is in X-ray. There's a false color image of this Milky Way galaxy resident. Next, we'll look at it in infrared and see if it has any signature on the Galix. And we see a heap and helping of nothing there in ultraviolet. And next, we'll check it out in pan-stars, the high-resolution optical survey. Nothing showing up there on pan-stars either. How about infrared? And here's the 2-mass survey. Nothing showing up on infrared. So that's an interesting one. The low-mass X-ray binary, almost entirely invisible except in X-ray spectra. So there's a zoom in. There's your close-up of that low-mass X-ray binary, whose name I will not memorize. It's IGRJ00291 plus 5934, another catchy name. And let's look at the astronomy picture of the day. It's a fascinating nebula here. This one is known as NGC 7023, the Iris Nebula. Another great example of a nebula with a bright star in the middle of it, as we see in nearly all supernoval remnant shells. Aesthetically pleasing. I'll have to save that one. And if you want to save it yourself, head to apod.nasa.gov and right-click and say Save As I just did. So yeah, that's a good one for the cosmology folder there. apod.nasa.gov, and that's today's cosmology segment. Let's move on to talk about electrons. They can produce charging hazards, but they aren't currently doing so. Everything green as far as satellite communications at the moment. Here is your one-year chart of the relativistic electrons, and we're actually at pretty high levels here again. Here's the 3-day chart. And it looks like we'll probably return back to warning levels again shortly here. We're just below warning levels here, which coincide with 1,000 pulse flux units or 1,000 particles per negative centimeter squared. Here's the relativistic electron forecast here, and NOAA forecasting a small downtick in the electron flux. I would tend to agree with this forecast. Maybe a little bit later for this big dip here, that's the arrival of the coronal hole wind stream, I would say. Here's a diagram of the Van Allen belts. Feel free to pause the video. Distances are shown in miles. Now we're showing the air column and the electron density therein. And the electrons are looking fairly organized here. The most likely place to find GPS errors is around the equator at noon, folks. And if you're new to the channel, we have actually demonstrated by riding the bike using a GPS only that these are pretty accurate. It's the total electron content. Next, we're going to show you a diagram of the atmospheric layers here, including the strata of the thermosphere, which is broken into multiple layers, by the way. The ionosphere includes the D layer, the E layer, and the F layer. And that's what we're looking at next. Here's the F ionosphere map. So some low-frequency anomalies showing up there in the southern hemisphere right away. This is vibrational frequency in megahertz. There's a lot of stuff going on above your head, folks. And this is one of the things, one slice of the atmosphere here, the F ionosphere layer. In many ways, the bridge between Earth and space. Lots of chemical reactions happening, lots of vibrations happening here. Anyway, there's the latest image from 11 o'clock Universal Time. Here's the anomaly map. We'll make sure this plays through one full day. Some high-frequency anomalies there around the equator near South America. You'll likely see some low-frequency anomalies in the southern hemisphere there as well. Fairly normal, though. So here's the latest image. That's at 11 o'clock Universal Time as well. There's the ionogram, and there's the anomaly map, which is departure from the 30-day median in megahertz. Meteorology, it's pretty sweet. Have you seen our meteorology segments playlist? We've got a bunch of playlists, youtube.com/smashamash/playlists. Here come your bonus features in the form of the latest imagery from El Teide, Spain. So the ground-based solar observatory here. This data only 2.5 minutes old from when we recorded the video. Coronal mass ejection watch relaxed here despite sunspot 2863. How do we forecast coronal mass ejections? Well, we can't really tell you. We've got to write a paper about it, and telling you in a video like this is not the way to do it. But there's the data regardless. There is likelihood of solar flares here as sunspot 2863 is beta class. The likelihood of sunspot 2860 producing any major flares detectable from the Earth is dropping as it sets in the southeast. So here's the latest refresh intensity gram. We've only got one sunspot group here at sunspot 2863. Here it is in colorized magnetogram. And it looks like it refreshed. And we'll refresh it again here just to make sure. You can still see the fields from sunspot 2860. Sunspot 2863 is now the relevant one to look at there, the magnetic fields. Again, it is beta class. It does have trailing opposite polarity umbrae. So this is North Pole. This is South Pole. And those type of beta class sunspots much more likely to produce major flares than the rest. It's not that magnetically complex at the moment. It could be intensifying as it did grow a little bit. Here's some more 304 angstrom imagery, ionized helium, and we're going to show you some composites to close out the video. More spectacular views here of the closest star, El Sol, from the SDO. If you've got comments to leave directly for the sun, leave them in our comments section, as nobody else on the internet is doing or able to do what our channel does. This is 304 and 171 angstroms composite. And we'll show you a close-up of the northern and southern hemispheres to close out today's daily space weather. Here's the north. No sunspots up there. Large filament rotating out of view there in the northwest. And there are some filaments around the northern portion of the sun here. Here's the southern hemisphere, complete with a great Earth scale there for you to compare the size of planet Earth and that sunspot 2863. The leading umbra is like about the size of planet Earth, pretty close. And we hope you're pretty close to pressing like and subscribe if you haven't done so. Thanks again to the Smash team, our patrons, everybody else viewing the videos, and may that solar wind be at your back.